Hello, everyone. So you're all here to say goodbye to proprietary caching APIs because now senior developer in the Hazelcast performance group, Jaromir Hamala, is here to tell you about JCache. So Jaromir has been programming since he was 7 years old and wants to know how things work under the hood. He's got some interest in JVM, how the JVM works. So please welcome on stage Jaromir Hamala.
Hi guys, I'm glad to be here and I'm very glad to see so many of you interested in a JCache API. That's great. So the title of my talk is JCache is here, say goodbye to a proprietary caching APIs. So the first part, that's the truth and that's a hard fact. There is nothing to argue about because JCache is here. The second part, well, the goal or my ambition for this talk is not to give you an answer, but to help you to find the answer yourself, because obviously this depends on your very use case or use cases you have. So I'm here to help you to find the answer. So who am I? So as I said, my name is Jaromir Hamala. I am a developer. I wrote my first line of code when I was 6 or 7 years old, I'm not sure. It was on the Eastern European clone of ZX Spectrum, if you happen to know this computer. I said clone. By clone, I mean a ripoff, but that's what it was. I work for Hazelcast, so this is sort of disclaimer because Hazelcast is one of the vendors of the JCache API. But my intention is to be as much vendor neutral during this talk as possible. So I will do my best, and I'm a big open source fan. So in my life before Hazelcast, I used to work in the UK for a small consultancy. So we did a lot of troubleshooting, performance tuning for mostly, but not only Java EE. And I can tell you a difference between having an access to a source code of the software you are troubleshooting, or middleware or library, or not having, can be a difference between spending 1 hour on site or spending 1 week on site. So I'm really believer in open source, not just because it's free and who doesn't like free stuff, but I believe in open source and because of its technical superiority when it comes at least for troubleshooting and this sort of things. And well, if I'm Chuck Norris or sometimes I'm the confused dog, we'll see about at the end of this session. I'm not a lawyer, but this is my sort of safe harbor slide. So everything you will hear may or may not be true. Please do not make any technical or non-technical decision based on this talk, because if you do, well, first of all, you are the silly one. Second, if you do and things go wrong, please do not sue me, do not sue Hazelcast. Right, that was silly enough. Now, finally, first technical slide. So, why we are using caching? Who is using any sort of caching? Can you please raise your hand? Okay, everyone, that's great. And who use caching to get things fast? Can you again raise your hand? Yeah, okay, almost everyone as expected. So yeah, exactly. That's why we are using it, right? Because system is slow, whatever it means, and we want to make it fast, and we want to make it, sometimes easy for ourselves. So what are the sources of slowness in the system? So one source of slowness might be something inherently slow, like speed of light. Unfortunately, the speed, the light is goddamn slow, so the round trip between California and Netherlands is about 150 milliseconds, and there is not much you can do about it. If you know what to do about it, please let me know. The other source of slowness might be algorithmic complexity. It might be maybe developer stupidity sometimes. There might be all various reasons. So, of course, to make things fast, that's the reason for caching. There is one less obvious reason about why we want to make things fast, and that's money, right? Because if you are, for example, on Amazon and you want to sometimes for example, S3, you pay by number of requests. So every request you can service from your cache, and you don't have to go to the third party where you are saving money directly. So that's great. That's what we like. And of course, there are different reasons as well for why we are using caches, but these are the, I would say, most common ones. I did some bit arbitrary grouping of approaches to caching, and I came up with 3 categories. So first one is very tempting, especially for us developers. So I want, just to cache some results from some remote API. Sounds easy peasy, right? I just use some concurrent hash map, maybe do something with TTL, some expiration. That should be a few hundred lines, maybe even less. And that's a very tempting thing to do. Well, from my experience, from my previous life before Hazelcast, I can tell you, do not do that. If I was given a penny for every memory leak I have identified and pinpoint to a custom caching, well, I would still probably have less than £1, but you got the point, right? It was probably not 100 cases, but close enough, because something, it seems really easy, concurrent hash map, what can go wrong? And well, maybe first year it's okay, but eventually, there are change requests. You change one line here, one line there. Suddenly, you have this pile of code doing some caching, having one or two threading issues, and well, no, do not do that. Really. Yeah, in my career as a troubleshooter, most of the memory leaks really were caused by custom caching. So do not do that. The other option is better. So you just you take Guava cache or cache or Hazelcast, whatever you fancy, and you use this proprietary implementation specific API. So the advantage is obvious, right? You are using code written by someone else. You don't have to maintain it, and well, there are thousands of people using the same code. Therefore, it's, well, if not bug-free, there will be definitely less bugs than in your own code. But of course, the disadvantage, well, vendor lock-in. Of course, if you're using cache, you depend on cache. And the third option, and the reason why you are here, I suppose, is that you want some standard API, and the JCache is the answer. So it is standard API for caching. So you can think of this as a JDBC for cache, hopefully better, because no one really likes working directly for JDBC. But the idea is very same. So you will have some APIs, such as in JDBC you have results head and this sort of stuff. So you are using one API, and in JDBC you have notion of drivers. So you use driver for Oracle, MySQL, whatever you like. And in JCache there is a similar concept called provider. So one API, multiple different providers. There is one fun fact. JCache has been developed under JSR 107 under the JCP umbrella, and it has been if not one of the longest running JSR ever, if not the longest running. So if you check the table, I hope you can see it. It took 13 years for something which seems to be quite simple. It's just a map. But finally it's there, and last spring it has been released, its final version. Good thing to know, it's targeted to Java SE6, so it does not have any mandatory dependency on Java EE, anything like this. So you just need Java Standard Edition platform, and you are good to go. So the slide before was somewhat abstract. So when I want to go concrete, I can divide JCache into three, or the features provided by the JCache API into 3 big groups. So first is the basic caching. That's what you usually imagine after when you hear cache. So it's some API somewhat similar to Java util map. It does not extend map for some reason, but it's very similar. The second group is eventing. So the cache can react on, let's say, put on updates and call your listeners, and your listeners can do stuff. So instead of, when, for example, you have a cache with stock prices, instead of just pulling constantly what is the price of one share of Google, you will be notifying if there is a change. So you can react on events. And third group is computation, some basic computation, but very useful, as hopefully we will see in a short while. So it's not anything fancy like MapReduce, but it's still very useful. And yeah, one warning, it's really API. So JCache does not describe anything about wire level protocol, anything about serialization, anything about data distribution, nothing like that. So on one hand, you can have a very simple implementation backed by, let's say, concurrent hash map. That's actually what the reference implementation is using. On the other hand, you can have an implementation using advanced network topology spanning multiple data centers, and all will use the same API. And yeah, so again, like a JMS, the same thing. You have API and you don't care about the implementations. So what implementations we have now? I think this is the last slide before actually coding. So currently, up to my knowledge, there are 4 implementations passing the compatibility kit. 3 of them are open source. So yeah, you can see it. And I know that there are other vendors working on a JCache compliant layers as we speak. So you can expect more to come. Okay, so one Scandinavian kernel developer once said, "Talk is cheap, show me the code." Who said that? Do you know who? Linus Torvalds. I hope I didn't mess up his pronunciation, but the author of kernel said talk is cheap. So I want to show you the code or the hello world, because everyone loves hello world, right? So the simplest thing, or actually not the simplest, but one of the simplest things what we can do. Can you read it? Yeah, perfect. So this is just my ordinary unit test. I have some setup method. Do not care about the content of the setup method as of now, but here is my actual test. So you can see that I have some cache, which is actually cache, which is like the map, right? So the key is integer, the value is string, and I do some operation. So I call put, then, well, I try to get it, and I'm calling the test, right? And then I do the replace, and then I do another replace. And that should be it. So let's try to run the test. And it will fail because it's demo, right? Yes, it's failing. And what it says is, no caching providers have been configured. Of course, because if I check my pom.xml, you can see my dependencies, right? So I have dependency on the JCache API. It's in a Maven Center repository, so you can just include it here. And then I have just some logging and JUnit, but I do not have any provider, no driver in JDBC. So I can just, use, let's say, the reference implementation. By the way, do not use reference implementation in a production. Reference implementation of JCache, unlike some other reference implementation, is not production ready. So there are some concurrency issues and races. Do not use it. It's just really for just demoing. So, and now, when I run the same test, it should pass. Yes, it's passing. So that's basically the JCache hello world. Again, ignore the setup method, and here what I'm doing really just put, replace. Here I'm doing, it's like compare and swap. So it used to be just in concurrent hash map. In Java 8, I believe the replace is even part of the Java util map. So basically it will succeed only if under this key is this string, and if yes, then it will be replaced by this one. And if this is true, then it will return true. Here is not the case because, well, I'm replacing hello world with hola mundo. Hope it's correct. So it will fail and will return false. So that was the hello world. And really a kickstart to the JCache. But before we dive deeper, we need some basic terminology, right? So there are 3 terms we need to know. First one is cache. That's obvious. That's like our map, right? The other one is cache manager. So according to specification, it provides means of blah, 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 blah. For now, for sake of this presentation, think of it as a cache factory, right? It's something what can produce the cache for you. and it manages its life cycles and these sort of things. But for now, Cache Manager is like a cache factory, right? Caching or cache provider, it's something on top of Cache Manager, and it can produce the Cache Manager for you. It sounds complicated, but it's not. The reason why it's there is it allows you a bit more scoping, and it allows you to have multiple cache providers from different vendors at the same time on a class path and this sort of stuff. So that are just 3 terms we need to know for now. So I did already show you the very basic hello world boring map-like interfaces, and I have cherry-picked a few features I like or I found interesting. The first feature is entry processor. So entry processor, I love it, and it's like a callable for a cache. So I give you an example, or I will show you an example. So here I have another demo. I'm not very imaginative when it comes to demo. So I have my employee. Employee has a bunch of fields like ID, name, salary. This employee, I have my random factory. So it's like a job center sending random guys to your work. So it will generate, ID, name, its salary, which is random, so it can be even 0. If it's 0, well, the guy is quite unlucky. But think of it, it's like interns. That's quite common these days, isn't it? People work for free as interns. Okay, so this will generate a random guy and put it to my map. And now I want to increase this guy's salary by let's say 100. So one way to do it, it could be, okay, live coding, I love it. I could do something like this. Some naive approach would be cache, get ID of my guy, local, only this, oric ample. Now I call increase salary by 100. The employee is immutable because that's. Yeah, I want to be loved by functional programmers, so it's immutable. And I will name this with increased salary. And then I can again call cache, put 0 with increase. So now the test should pass, but, oh, it's not. Okay, cache is okay. I mess up my initialization. We will come to this later, but let me fix it. The quickest fix will be this one. Oh, it's there. So the name of the cache is EP. Okay, I'm using, okay, so I will switch from the dereference implementation to Hazelcast. The reason is that I'm using a declarative cache definition, and declarative cache definition is not part of this spec. So in a spec, if you want to be 100% compliant just with a spec, you have to use a programmatic cache definition. In this demo, I'm using the declarative cache definition, which is basically just this line, and this one is even not necessary. So I need to use a Hazelcast because this is Hazelcast specific descriptor. So now, hopefully the test will pass. It takes a while because by default, no, okay. So it's green, but as I said, you don't have to be a duckly to spot a problem, right? Because, well, it's concurrency. Because if 2 threads will try to increase the salary, at the same time, one update might get lost, and, well, the employee will not be really happy, I assume. So the other way around could be to use this compare and swap, right? So we would have the loop which would try to increase the salary and to do replace if the original employee is the one with the original salary. That we do not want to do that. The reason is that even with the original approach or the one which is slightly better in terms of concurrency, the problem is that the JCache implementations are quite often well distributed. So the data are distributed between many JVMs or even computers or data centers. And just to update one attribute, the salary, what this code is doing is first sending the full object employee over the wire to my local box when this code is running, and then it just changed one attribute and then sending full employee back where the data are stored. That's not really great. So the entry processor approach would be this. So here I'm defining a transformation function. In this case, it's lambda, and what is it doing is it's basically an algorithm to increase the salary. So, and when I have this function, think of it as a callable, I will call cache invoke on this key, invoke this lambda, and pass it 100 as an argument. And inside, well, I'm doing, you can figure it out yourself. The advantage of this approach is over the wire, I'm not sending full employee there and here and there. I'm just sending the transformation function. And the other advantage is, according to specification, this is supposed to be the atomic. So we do not have these races. So this is the approach with entry processor, and I really love it. And from my experience at Hazelcast, I can tell you that people do not know entry processors, and what they tend to do is really send data here and there, and that's not really great for performance, right? So entry processors are awesome. That's what I want you to remember. So if you will ever use JCache or even proprietary API which provides the entry processors, please use it. Learn how to use it, because they are great for this sort of things, because yeah, really they will provide you atomicity, you will transfer less data, everything will be faster. The second feature I have cherry-picked are listeners. So as I said, your cache can react. So if in my cache I'm storing the shares, and there is an update, then I can have multiple listeners which will react on this. So I have again a very quick demo. Hopefully it will work this time. So listeners. So here is my test. Again, do not care about the configuration for now. This is, by the way, the example of the programmatic configuration. It's quite verbose. That's why I prefer the declarative one. And here you can see that I have my cache. Again, it's a integer and string, and I'm just calling put. And when I call it, and here I have a listener entry, listener factory. So when there is an event, then it will call. Yeah, it will just call toString of the event. So let's try it. Yeah, so you can see that I got 99 or 100 because it started from 0 events. And yeah, so the listeners, so the cache produced the event on put and call my listeners. My listener, I have just one here in this example. JCache defines bunch of interfaces. Each has just a single method, so it's quite Java 8 friendly. And yeah, so you can listen on a creation, and you can see it yourself. I don't have to repeat it. And the last feature I have cherry-picked is cache loaders, cache writers. So it will allow you to have a read-through or write-through caches. So example is that when you, for example, for the cache loader, when you call cache get some key and the key is not in the cache, then the usual approach is, okay, so there is miss, so your code would have to get the value somehow by calling third-party API or do a database lookup or this sort of things. The idea behind read-through is that the cache will be responsible for loading this data. So again, the API is really simple. So you have cache loader, you implement just these two methods, so load and load all. That's for some bulk loading. So if you have a storage or third party with high latency, you can benefit from the bulk operation. And you register the cache loader, you enable the read-through, and that's it. So again, I have this example. So I have my cache loader. So I implemented these two methods, and it's very naive implementation. So when someone calls load, I give you value which is just from storage underscore a key. So in a real world, I would probably do, I don't know, database lookup, code third party. You can imagine that. And the test itself, again, this is the programmatic configuration. So I enable the read-through. I pass it the cache loader factory, and I call the test. So you can see that the cache is empty. There is no data being filled to a cache. But when I call it, you can see that if I'm iterating over the keys, they are written. So this is the read-through JCache. And again, if you check the imports, they are all from spec. There is nothing specific to my Hazelcast implementation. So I could do is I could go to the Maven to POM, switch the implementation. So I will comment out Hazelcast, and let's say I want to use InfiniSpan. Okay. So now on my class path will be just InfiniSpan. When I run the same test, see, it's exactly the same behavior. So I was able to switch my provider, my caching provider, and the behavior is exactly the same. So there is a yin-yang, and there are cache loaders, and so the yang would be cache writer. So it's very, very similar. It allows you to write through. So when you call cache put, it will not only store the data in a cache, but the JCache implementation will call your writer, so you can write the same data to database, called third-party API, etc. The API is slightly more complicated, two more methods, because of course delete method. So when you call delete, you want to let your persistent layer know. So, but it's the same thing. So I have this section called other features. And other features does not mean less important features. It means, for sake of this presentation, features I do not have a demo for. So the other features, the first one is I picked is our annotation. So the JCache spec defines a bunch of annotations and the behavior. And if you are in a managed environment such as Spring Framework or hopefully Java EE8, hopefully, then you can just annotate your bean, being Spring Bean, EJB Bean, CDI, whatever, with one of these annotations, and the container is now responsible to cache the results. So if you have some slow service, well, you can declaratively say, well, cache me the results. So good thing is that now we have this annotation as a part of the spec. Because, for example, Spring used to have and still have its own annotations, but now these days the Spring supports both. So its own Spring-specific annotations and this annotation as well. Expire policy, that's another important feature, and this feature is quite often not part of this custom homegrown caching stuff. So you can say, okay, I want to cache my stuff, but I do not want to deal with any values older than X time units. So you can say, okay, this is too old if the last access was more than 100 seconds ago, or this sort of things. So you can configure this by using the standard API only. JCache also defines a statistic, so you have visibility into what's going on. It exposes the stats via, let's say, JMX. So you will see your cache hits, cache misses, and you have a standard way, to monitor it. So that's great for people in operations, because they finally they know what's going on and they have a standard way to monitor this. Store by value versus store by reference. That is as I said, the cache is more or less like a map. It feels like a map, but there is an important distinction. So in a regular map, everything is stored by reference, right? So you store something, and in the map itself is just a reference. In cache, it's different. There is by default behavior that there is a value. So it will actually create a copy of your stuff instead of just keeping the reference in place. That's the default behavior. I am not from the expert group from JSR 107, but I believe the reason here, sorry, is that, as I said, the implementations are usually distributed, and it's quite hard to do store by reference over multiple JVMs. So it's by default it's store by value. The specification defines store by reference as well, but that's just an optional feature. So it may or may not be in your implementation. Right. So integration. So of course no specification lives in its own universe. So we want to somehow integrate it. So currently, the best integration of the JCache, at least when it comes to these annotations, is in a Spring framework. So as of now, when you start to play with a Spring framework, you can use this standard specification from JCache, and it will just work. So it's already there. For Java EE8, Arun Gupta was talking before me on this stage, and the JCache was included as to be part of Java EE8. I would love to see it there, and I will do everything I can to have JCache there, but it seems as it is quite a lot of work, because what does it mean integration? So you can just maybe make the EJB container to be aware about of these annotations, or maybe you want to use JCache for caching in your JPA as a second level cache. Maybe you want to cache something else. So there are quite a few integration points, and up to my knowledge, there is not much activity going on, unfortunately, right now when it comes to integration with Java EE8. So please, if you want to see this nice stuff in Java EE8, please tweet about it. Tweet about it now. Just write a tweet. I want JCache in Java EE8. If you want it, of course. Write blogs and be vocal. Because otherwise there is a risk that it will not be included there. So please let everyone know you want to have JCache in Java EE8. And the example or demo or prototype how it could be done is, how many of you know Payara? Payara, okay, just a few. It's a more or less fork of Glassfish. It's being so C2B2, again disclaimer, C2B2 is a company behind Payara, and it is my former employer, and I still think they are awesome, so that's why I'm mentioning it here. So they take Glassfish, the upstream, they fix the bugs, and they release it every 3 months, I believe. So you have fixed release cycles and you have bug fixes, and they have some enhancements which are disabled by default. But you can enable in Payara in the latest release integration with Hazelcast, and they provide JCache as a part of Payara. So then if you have a servlet, you can just it can inject the JCache stuff for you into your servlet or to EJB CDIs and this sort of beans. I have a demo. I'm not sure about the time. Maybe we have time for demo. Okay, but I will show you the Spring demo. So I have a very basic Spring Boot application. It's more or less just the app from a tutorial on a Spring Boot for WebSockets. So when I started, Okay, it's starting. Okay, it's running. Okay, so that's very simple WebSocket web app. So it asked me what's my name. So my name is Jaromir. I will send it. It seems that it's doing nothing, but actually it's doing very complex business logic, as you can see. And there is my very enterprisey service, which I call slow service. And it's very sophisticated, as you can see, and it's slow. Because, yeah, it's slow. And so this is my Spring configuration, and I would like to, well, I don't know how to fix it really, it's so complex. So I want to cache its result. So in order to do so, I will stop it, and I will use my cheat sheet. So first thing what I will do is I configure Spring to use a declarative caching configuration, so enable caching. Then I will create a cache manager. Now this cache manager is not the cache manager, it's actually here, is not the cache manager from the spec. This is a Spring cache manager, but the implementation of this cache manager is from JCache. It's kind of confusing, but the Spring will use this bin to access the JCache cache manager. And the last thing is that I will use JCache annotation, so nothing Spring really specific, and I will annotate this one. So I import it, and I will start the application again. I cheated a bit because in the build Gradle I have already predefined 3 more dependencies, as you can see here. So I added JCache API and my implementation and one more jar. The reason why I did it is because IntelliJ IDEA is sometimes quite slow with Gradle, so I wanted to have this on my class path. So now it's running, and let's give it another try. So I will connect again. What's your name? So it will be slow. The first execution should be slow, or will be slow, because it's not in our cache. Okay, but the subsequent execution is fast, so because it's going directly from the cache. And again, as you can see in the service, I'm using the standard annotation, nothing Spring specific from the JCache interface. So I believe and I wish that one day, hopefully at the day when Java EE 8 will be released, you will be able to do the same thing in your Java EE application. So you will just annotate your service method in your EJB or CDI bin as a cache result, and it will just work. So that's my big wish. And if you want to do the same, so please tweet it, and tweet it now. Tips and tricks. I promised some tricks. So the first advice is obvious. Try to stick to the JCache API if you can. But if you can't, because it does not provide something you need, then please encapsulate your implementation specific code, because you really do not want implementation specific code in imports to spread all across your application, because then what's the point of using JCache? So encapsulate it. The other advice is be careful with the default caching provider. I will show you what I mean. In my Hello World test, the way how I am obtaining the caching provider is this. That's from the spec. So there is a caching class that's part of the spec, and it has a static method get caching provider, and it will give you the implementation of caching provider as long as you have exactly one provider on a class path. So that's my case here. So when I call the run, Yeah, it's working. But let's say I have two providers. So I have InfiniSpan and I have a Hazelcast. And when I run the same test, it will fail because it says multiple caching providers has been configured when only a single caching provider is expected. It doesn't sound as a big deal, but think of this situation. You have your Java EE web app, and it contains a jar with your JCache provider, with your JCache implementation, because, well, it's not part of Java EE7, right? So you have this var and it's running on Java EE7 servers. Now, if JCache is part of Java 8, you deploy the same var to Java EE8 container, and what will happen? Suddenly you have your own provider as a part of your var or E or whatever, and you have another provider as a part of your platform, right? So things can be funky, so you will start to elaborate with parent first class loader, parent last, this sort of stuff. So I'm not saying do not use this one, but this method, but be aware of consequences. So maybe somewhat controversial advice would be maybe even avoid using this. So the way how to avoid it is that you can pass the name of the implementation you want to use. So in the case of Hazelcast, for example, the name of the class, of course I don't remember it from the top of my head, is this one. So what I can do is copy and paste it. Hazelcast caching provider. Okay, so now it should work again. Let's give it a try. It should pass again. Yeah, Hazelcast is starting, and it's green. So this is one way to get around it. I'm not saying, and of course this string should be externalized somehow. I'm not saying use this, but all I'm saying is be aware of consequences if you use this form, because there might be consequences. The other, no, it's not trick. It's just all I'm saying. Entry processors are awesome, really. If you are using JCache, learn the entry processor. They are great. If there was one thing you to remember from this talk, remember this: entry processors are awesome. Now, missing bits. What's not part of the spec, and sometimes is nice. The single most important, at least for me, feature is the lack of async interface in the spec. So currently the methods on the cache are all sync, so they're blocking. So if you call get and you have a distributed cache, so it will send a request to the node where the data are stored, and the response will go back, and your thread will be blocked all the time. That's usually not a big deal, but in some environments, if you are using a Vertex or Netty, it can be a problem to block the thread. So unfortunately, the async interface, I can imagine that the get could return, or there could be a variant async get, and it would either return completed the feature, or you could register a completion listener or something like this. It's not part of the spec. Vendors usually provide ways how to use it. So even in Hazelcast, we have the proprietary extension, but it's not part of the spec. So that's missing piece. The other missing piece is eviction. I mentioned this expiration, but expiration works on an entry level, right? So it will guarantee that no entry is older than, let's say, 10 seconds. But there is no portable way how to tell, okay, I want my cache to always use less than 25% of my heap, for example. And it's up to the cache to use an algorithm to evict some entries in order to stick with this size. So it can be least frequently used, last recently used, something like this usual algorithm. Unfortunately, this is not part of the spec. When I learned this, I was really surprised. I was like, come on, this is the basic feature I would expect from a cache. It's not there. Why? So I asked the guys from the expert group, and they were like, yeah, it sounds simple, but it's not. The reason why it's not is because in the real world, usually the cache implementations, they have multiple tiers. So first, you have some hot data which are stored in a Java heap. Then you have some little less hot data that are stored in other heap storage, and then there is some overflow to a disk or something like this. So you have multiple tiers, but in JCache there is no notion of this tier. So how would you configure eviction? Would that be the overall eviction, or would it be per tier? And this sort of question. So as we speak, it's not in the JCache. I hope it will be in the new version eventually of the JCache. Currently, the eviction is mentioned in the spec as implementation detail, and I think most, if not all, providers of implementation, they provide ways how to configure eviction and the querying. That's another missing bit. So currently, you can call get key, but you can't query it. So you can't tell, okay, give me all employees with a salary equals 10 or more than 10,000 or something like this. So you can't do it using the JCache API only. So if you are interested more, the best sources are, of course, the spec itself. The spec has about 130 pages. That's not that much, especially when you compare it with some other specs, and quite a few pages are just code listing, so there is not that much text, so you can read it quite easily. The other good thing is that JSR 107 has been developed mostly on GitHub. So on GitHub you can see the spec, you can see the API, you can see the reference implementation. I repeat again, it's not production ready, but it's there, and I believe there is even the technology compatibility kit, but I'm not sure about its license. And the other source is the JSR 107 forum. So again, please, after you tweet, I want JCache in Java EE8, please go to the forum and write the same. So I don't know if we have any time for questions. Okay. So if you have any question, just feel free to ask. If not, then we can discuss it here after the session. Okay, so I have a question for you. If you don't have any question for me, I have a question for you. So before the talk, most of you raised the hand like you were already using some caching. So who will try the JCache in the next project? It's quite a few. That's great. That's perfect. There's a question.
I was thinking about persisting the cache. Is there any effort to standardize?
Well, as far as I know, the only way for how to persist the data outside of your cache, you mean, is it the cache writer? Is that what you mean?
To persist the entire cache, to have it persisted.
So you could use the cache writer, right? So everything, so you could, that would have to be your own implementation of the cache writer interface, and then everything what you put to a cache would be transparently written to the persistent storage of your choice. It's up to your implementation, but there is no way, the specification is not talking really about persistence as of now, and I'm not aware of any activity here that towards making the, I don't know, what would that be, binary format or something like this persistent. Of course, different implementations, it's up to implementation to provide the persistence, so it still might be there. It's not something against the implementation. So I think Infinispan has a persistent storage working out of the box, I think. So there are ways, but it's not part of the spec per se. It's implementation detail. Any other question? So if there is no other question, I want to thank you for your attention. It seems no one is sleeping. I'm very surprised. So at least I can't see anyone. Maybe someone is, but it's well hidden. So once more, thank you for your attention, and enjoy the rest of the conference.